Okay, now let us see how we handle this example. We are going to see how we expand this and we get this probability, but let us start with this. A large number of random sample sizes n are taken from this. So whenever they give you this one means that it's a binomial. So our solution here, so this is a binomial of 20, 0.2. Remember our binomial score is given by n, p, where p is the probability of success and n is the number of trials. So what they are giving us this so that we can easily read our expectation. Approximately 90% of the sample mean are less than this estimate A. Now from here, we say that the sample mean of the original population is the same as the sample mean of the population. So if we get a population where they go to this binomial, it will be the same as our mean. Our mean, remember for binomial, is given by NP. This is our now 20 times 0.2. So here our mean will be 4. Now that's the first part. Now we're telling us that the probability approximately 90% of the sample mean. So the probability that you get a sample mean less than 4.354 is 90%. So in simple terms, they are giving us the probability by in terms of percentage, and this will be 0.9. So after giving us that, now this is a this is a sample mean. So we standardize it. This will be now probability of now z less. This is now our x we are dealing with. 3, 5, 4. Then minus our mean. Our mean this time is 4. The whole divided by our standard deviation or sigma. But we don't have sigma, but we can get it. Then or we don't have sigma, so our sigma here is equal to root of NP cube. Our NP cube, which will be square root of, let me write it here. Our sigma is equal to root now of n. So we have first of all 4, then times our cube. From here, if p is this, then our cube is going to be 0.8 times 0.8. And so this will be multiplied by 0.8. So root 4. So my sigma here is giving me a root of 3.2. So now I have a root 3.2 as our sigma, then divided by the square root of n, but my n is 4. But the whole of this is equal to 0.9. So what happens if we simplify that? We don't know the sample n, so we don't know this n. This n is what we are looking for. We don't know this n. This n is what we are looking for. So this n is what we are looking for. So after that now, I can simplify the whole of this too. Now the probability of, we get this, we have root. Okay, I'm going to be having the whole of that as 0.354 divided by the root 3.2. So what I'm having, and then I get the solution to this will be z less than 0.1979 root n equaling to 0.9. Then I consider this as my probability of z less zb equaling to 0.9. And then I come and I draw a simple sketch for that. For this, if I draw that simple sketch here, I'll be having this case here. Less than 0.9, it means that to be less and it's in the positive, it should be greater than 0.5, which is the case. Our z will be here. This is our, so this is the parameter they are giving us. We need this z. But the same, the whole of this from here is 0.5 plus b will be equal to this probability of 0.9. So start from there. My P is 0.4. After getting my P, now I come and I get my Z. My Z will be, you go in your table and read 0.4. So from here, let me show you how I'm getting it. You see my table, 0.4. P is 0.4 from here. My P, this is the P, is 0.4. So 0.4 is there. Then the corresponding value of Z, I think you see. The Z value is 1.282. 1.282. That's the corresponding value of Z. So now meaning that the whole of this is not my ZP. So from there, my 0.1979 root n is equal to ZP equaling to 1.282. So it's that my root n there is going to be, if I get that and I divide by that one, I get 1.2. I get 6.4780. If I square, then my n will be, if I square both sides, 6.478. I'm getting 41.96481. So it's like our n here is approximating the next integer, which is 42. Now, that's how we handle this. If they are giving us a binomial, that's the way to go. As simple as that. Now, what happens to this? We come to a random variable x. This one shows it's normally distributed with mean, mu, and then variance form. A random sample of size n is taken from a population, find the list n so that this is equal to this. So from here, if we are to start with this, they are giving us that n follows a normal, the mean mu, and then 4. Mean that, remember, this is always n, mean, then sigma squared. And then our sigma squared is 4. So we need always our sigma, which is 2. Then mean, how we get a mean? From there, now they're telling us that taken from satisfying the value of n such that this is true. Why do we have? We have this as, so if we are to handle this now, we have probability of magnitude of x bar minus mu, the whole less 0.5, and telling us that this one is equal to 0.95. What happens? We know how to expand this, but we say that this is the same as probability now. We take everything the other side, negative 0.5 less x bar minus mu less 0.5 equaling to 0.95. When I put this, I take this side, so this will be the probability of negative 0.5 plus mu x bar 0.5 now plus mu equaling to 0.9 and then 5. Then you saw that now we need a moment. Sorry. Okay, now from here, this is our expander. We need to standardize it so that we can read this. How do we standardize? So we standardize by, this will be now a bit of negative 0.5 plus mu. We say we subtract the mean. So our mean here is this. So subtract mu, the whole divided by our sigma 2 over root n. Less, now this one becomes the less. This is now acting as our x plus mu, then minus mu. Now all over 2 over root n equal to 0.95. How am I doing this? Because so that from here our z will be x minus mu over sigma root n. So that's where I substitute. So it's that this one is equal to 0. When I divide it here, I have probability of negative 0.25 root n less z less 0.25 root 2n equaling to 0.95. And we said if this and this are the same, this is the same as 2 twice the probability 0 less z less this 2.5 root n equaling to 0.95. Divided by 2, then our probability of 0 less z less 0.25 root n is going to be 0.475. Now we read this. Now we want, this is what we want, 0.7 less ZB. Now with this, we want this B, so that this one is giving us 0.475. And we have sketched that. That one is the easiest to get really. So it's that this one is from 0 up to ZB, up to ZB. So this is the probability we want. So just know and read the probability. I mean, we get the value of Z when the probability is this, you need this ZB. Now I'm going to show you two methods, but I don't know what you take. So the first one is, you see, when you want that value of 0.47, you see 0.47, sorry, we are in cumulative. You see that 0.47, you look for it in the table, 0.7575, you see it's here. You see it's here, 7475. 475, so it's 1.9 and it's 1.9 and 6. So it's that this one is, now it's that there, our ZB is going to be 1.9 and 6. The other way, you can use now the critical table, this critical table here. What do we do? Let me show you better this at once also. Now, some cases is that we need, the P we need is 0.475. So when you come to our P here, is that this is 0.74 and this is 0.75, meaning this is in between. What you do, you get the Z of this, which is this, you add the Z of this one, then you divide by 2. Like here, I think you can see. The Z of the first one, I think, let me do it so that you can see. Like this. This Z of the first one here is this, which is this. Then the Z of the second, which is this. So you see that our 4.75 is between here. When you add them and then you divide them by 2, you get the same answer. I think you see it there. So after doing that, or after learning that, now, mean that now my Z there, so then now mean this is the probability of 0, less Z less, this is the value, 196, that gives me this probability. So now, you start this one is equal to this, so in simple terms, R0.25 root n is equal to ZB equaling to 1.96. So I think we start our n from there. If you get our n, you get 1.96 divided by 0.25, then you square. The answer we get here is 61.4656. Give it the next integer. The next integer after this is 62, and that will be our answer. So that's how we handle that members. Now we are going to see the confidence interval in the next lesson. See you.